Have you ever stopped to wonder how researchers take a big, abstract idea like happiness or brand loyalty and turn it into cold, hard data? It all comes down to measurement, this fascinating art and science of assigning numbers to the world around us. So how do they actually do it? Well, let's dive in and find out. I mean, you see questions like this everywhere, right? It's second nature. A 1 means your day is terrible, a 5 means it's fantastic. We answer these things without even thinking about it. It just feels right, doesn't it? We're using a scale to put a number on a feeling.
But wait a second, let's really think about that. If you rated your day a 4 and I rated mine a 2, does that mean your day was literally, mathematically, twice as good as mine? Probably not, right? And that simple little question uncovers a massive challenge in all of research, making sure the numbers we use actually mean what we think they mean. To get this right, you can't just wing it. You need a formal process. This right here is the official textbook definition of measurement. It's all about creating a consistent, standardized set of rules to turn a characteristic, like your mood, into a symbol, like the number 4. And believe me, in measurement, those rules, they are everything. So that's the core problem we're trying to solve. How do we build a solid bridge from a complex, kind of fuzzy concept like happiness to a clean, simple number we can actually analyze? The answer is all about choosing the right tool for the job. And if you get that choice wrong, your entire study can fall apart before you've even started. And that brings us to our toolkit, the 4 fundamental scales of measurement. Now, don't think of these as boring definitions from a textbook. Think of them as tools that get more and more powerful, more and more sophisticated. We're going to go from a simple sorting hat all the way up to a high-precision scientific instrument. First up, we've got the most basic tool in the box, the nominal scale. Its only job is to sort things into different groups. That's it. We might assign numbers, but they're just labels, like 1 for male, 2 for female, or 1 for team A, 2 for team B. A 2 isn't more than a 1, it's just a different box. Okay, let's level up. The next tool, the ordinal scale, adds a really crucial piece of information, rank. It tells you the order of things, like who finished first, second, and third in a race. But here's what it doesn't tell you, the distance between those ranks. The winner might have been just 1 second ahead of second place, but second place could have been a full minute ahead of third. We know the order, but we have no idea how big the gaps are. All right, now we're getting some real power. The interval scale, and the classic example is a thermometer, has equal steps between each point. The difference between 10 and 20 degrees is the exact same as the difference between 70 and 80 degrees. But the really interesting thing here is the 0. 0 degrees Celsius doesn't mean there's no temperature. It's just an agreed-upon point, the point where water freezes. Because that 0 is arbitrary, you can't say 20 degrees is twice as hot as 10 degrees. And finally, we have the most powerful tool in the whole kit, the ratio scale. This has everything the others do, plus the real game changer, a true absolute 0. Think about things like weight or money. $0 means you have literally no money. 0 pounds means something has no weight. Because that 0 is real and absolute, we can finally make those proportional comparisons. Someone earning $100,000 a year really does earn twice as much as someone earning $50,000. This table lays it all out beautifully. You can see how each scale builds on the one before it. It's like adding a new power-up at each level. Nominal just tells you things are different. Ordinal adds order. Interval adds equal distance. And ratio gives you the whole shebang with a meaningful 0. The further down this table you go, the more powerful your analysis can be. And that's exactly why choosing the right scale from the very beginning is so important. Okay, so we've got our 4 fundamental scale types in our toolkit. But how do we actually put them to work in the real world? Let's look at 2 of the most common ways you'll see them used, especially in surveys: rating and ranking. The difference here is really simple, but it's crucial. A rating scale asks you to judge something on its own. Your 5-star rating for a coffee shop has nothing to do with how you feel about other cafes. But a ranking scale forces you to compare. You have to decide if you like coffee more than tea. There are no ties for first place. You've seen these a million times, for sure. You've got your simple dichotomous scale, just a yes or no. Then you have the super famous Likert scale, our classic strongly agree to strongly disagree 5-point system. And you've probably also seen a semantic differential scale, where you have to place your opinions somewhere on a line between 2 opposite words, like good versus bad. Now, when it comes to ranking, researchers have a few clever tricks. They might use what's called a paired comparison, where they just keep asking you to pick between 2 things at a time, prefer A or B. Okay, what about A or C? Or they might just give you a whole list and say, rank these from your most favorite to your least favorite. That's a forced choice. Either way, they're making you prioritize.
All right, so you've picked your scale, you've designed your perfect survey, but how do you know if the tool you've created is actually any good? This, my friends, is where we get into the quality control of research. This is the million-dollar question for every single researcher out there. Because if your measurement tool is flawed, then all your results are basically meaningless. To be able to trust your data, you have to check for two absolutely critical things: reliability and validity. Let's break this down. Reliability is all about consistency. If you step on your bathroom scale and it says 150 pounds, you expect it to say 150 pounds again a minute later, right? That's reliability. Validity, on the other hand, is about accuracy. Does that scale actually measure your weight, or is it off by 20 pounds? You've got to have both. And this dartboard analogy just makes it all click. Look at that first board. If your darts are scattered all over the place, well, that's not consistent or accurate. It's just a mess. Now look at the second board. The darts are all clustered together, which is great. That's high reliability, but they're nowhere near the bullseye, so it's not valid. The goal, of course, is that third board. All your darts are clustered tightly right in the center. That's the sweet spot: high reliability and high validity. So what's the bottom line here? It's that a tool that's consistent but wrong is useless, and a tool that's sometimes right but totally inconsistent is also useless. For any research to be worth anything, it absolutely must have both. It has to hit the same spot every time, and that spot has to be the bullseye.
This quote sums up the whole relationship perfectly. If you are truly measuring the right thing, if you're actually hitting the bullseye, then by definition, you have to be doing it consistently. But just because you're consistent, just because you keep hitting the same spot over and over, that doesn't guarantee you're hitting the right spot.
So the next time you see a survey, or read a study, or see a news report with some flashy statistic, just pause for a second. Ask yourself, what kind of scale are they even using? How do we know it's reliable? And most importantly, are they really measuring what they claim to be measuring? Once you start asking these kinds of questions, I promise you, you'll never look at data the same way again.